Seasons. It takes about 8 minutes from the sun's light to reach the Earth. How and where the sun's light hits the Earth will affect its climates, temperature, and also seasons. The Earth's axis is tilted about 23 degrees from the vertical. The equator is the horizontal line through the center. The sun's rays will hit the Earth at different angles. This angle will determine how hot a particular region of the Earth is. When the northern hemisphere is tilted away from the sun, the equator and southern hemisphere will receive the majority of the direct sun rays, and the northern hemisphere will receive direct sunlight. This direct sunlight is not as strong as direct sunlight, so that is why the northern hemisphere will be colder than the equator and southern hemisphere. The southern hemisphere will still receive indirect sunlight, so it will still be cold. As the Earth moves around the sun, the northern hemisphere will start to tilt towards the sun. The light will still take 8 minutes to reach the Earth. But now, the northern hemisphere will be tilted towards the sun. This will result in more direct sun rays will hit the northern hemisphere and will result in the temperatures rising. Let's see what would happen if our Earth was not tilted 23 degrees and was in fact straight up and down on a 0-degree tilt. We would still see more direct sun rays along the equator, and the poles would receive indirect sunlight and would be colder, but the temperatures along those regions would stay the same throughout the whole year. As the Earth moves around the sun, the poles remain and the temperatures will not vary much between the North and South Pole. We will still get direct sun rays along the equator and indirect sun rays along the North and South Pole, making them cold. This occurs in some planets like Jupiter, where the poles are situated with 0 degrees and we have no change in temperatures throughout the year. The sun's rays will hit Jupiter in the same way they do the Earth, where we get more direct sunlight along the equator and indirect sunlight along the equator, making them colder and making the equator hotter. And as Jupiter moves around the sun, the North and South Pole still stay at a 0-degree tilt, and therefore we will have no change in the temperature in the North Hemisphere and the South Hemisphere. The equator will still be hot compared to the poles. However, it will be a lot less hot compared to the Earth because Jupiter is so far away. The tilt of some planets is so extreme that they also have extreme seasons. One example of this is Uranus. In this position, the southern hemisphere is going to be so warm because there's such a tilt, and the equator and the northern hemisphere are going to be so cold. As Uranus moves around the sun, now the northern hemisphere will be tilted towards the sun, and now the northern hemisphere will be really warm compared to the cold southern hemisphere. However, because Uranus is so far away, it will still be quite cold compared to the Earth. Let's compare the axis tilt of the different planets. Looking at Mercury, Jupiter, and Venus, we see that these planets are almost straight up and down. However, Venus has poles that are almost reversed. All of these planets have no seasons. Uranus and Pluto are tilted almost 90 degrees, which gives them extreme seasons. All the other planets have tilts similar to that of Earth's, and therefore have similar seasons. Another interesting fact is how the sun changes throughout the seasons and how it appears in the sky. The winter sun is angled a little lower in the sky, and the sun's rays hit the Earth on an angle. This is indirect sunlight. This is the shortest day of the year, because the sun travels less distance and is lower in the sky. There's also the longest shadows during this period. As the Earth moves around the sun, its position in the sky will change. Now we see the summer sun. Here the sun is higher in the sky and we receive more direct sunlight. June 21st is the longest day of the year, known as the summer solstice. Here the sun stays out longer and has a longer distance to travel as it moves across the sky. But remember, it's not actually the sun that is moving, it is the Earth that is rotating between night and day.